All right. So, as I said today, I said the inspirational part. I don't know if that's necessarily a good thing to call it, but today we're going to start talking about uh, some modules that allow you to do some really high level things, like um, basically manipulating data as data, um, rather than getting down into the weeds all the time. Now, it still allows you to do that, but these are tools that you've probably heard like a buzzword nowadays, data science, right? These are tools that data scientists use to manipulate data, and this actually um, is actually becoming very, very popular in that region for manipulating data. The tools that we're going to talk about today, and ArcGIS has coupled their product, the ArcGIS software, with this tool that already exists for data scientists. So that tool is called Pandas. So today we're going to talk about how Pandas and ArcGIS work together. Pandas is a library that it's a Python library, and it actually allows you to. Well, I'll say the first one for. Make this a little bit bigger. Let me make. Yeah, there we go. It's about as big as it gets. It still fits on the page. It really would be nice if that wasn't. So this Jupyter Notebook is actually up there on the course website right now. So if you download it and open it, you can get there. So basically, Pandas is kind of like Microsoft Excel. It kind of fits in that same niche, but it's all very scriptable. Like, in other words, you can write a Python program to interact with it. It doesn't just come up in a GUI. It allows you to inspect data to add up all the values in a column, or add up all the values across a row, or take this value and that value, and we're gonna step through it. Okay. Now, the goal at the end of this class isn't so much that you are going to be a Pandas master, but it's to show you that this is a powerful tool for doing data analysis, and to get you to start thinking about that. So the assignment today will be more about finding some data. Like, once you understand what Pandas does, it'll be about finding data that we can analyze in Panda, and then coming up with a suggestion of how we might be able to analyze that, knowing that it can create graphs and charts and whatnot. And so that'll be the assignment, is to identify data and then come up with a story that you want to do with it. And then next week, what we're going to do as the lecture is that I will execute some of those stories in a Jupyter Notebook, because that's really what a Jupyter Notebook is. What's kind of cool about a Jupyter Notebook is that you can tell a story in code. Okay. So that's what it does. So basically, Pandas works with tables. They call the table a data frame. So Pandas calls tables a data frame, and I know ArcMap called the map area a data frame. It doesn't have anything to do with one. Doesn't have anything to do with one another. That's just what they decided to call a single table element is a data frame. It holds your data, and we'll talk about that. It does. Once you kind of get what it's doing, it makes it, like it says, easy and intuitive. It's basically like a super sequence. It's got some elements of a dictionary and some elements of an array and some elements of a list. It's got some in common with all of those, and we'll talk about that. And it really doesn't have anything to do with the cute animals from China. It just has that name. Okay. So why would we want to use Pandas? I've got some lists here. There is a website for pandas. I forgot to put the URL for pandas.
Are you recording stuff?
I am.
Okay.
Yeah, so let me put, I mean, the URL for, oh, there it is right there. No, that's not. Okay. So let me put that in here. So it's just pandas.pydata.org is the website. So let me just put that in there.
So Panda is Python?
Panda is a kind of like ArcPy. It's a library that is written for Python. Pandas.pydata.org. Let me put this in as a
library and module.
Library and module are right. Those are what do you call them? Similar terms. Synonyms. Yes. There we go.
So why was Panda written just to perform that task for data in certain type of data?
Oh yeah, so I mean you'll see here in a second, but you know, like it basically allows you to interact with rows and columns of data in much faster ways than, like for example, we interacted with tabular data earlier in the semester, like 2 or 3 weeks ago when we did cursors, right? And so you can go through and you can look at each element, but you have to be in a loop. There are some tools for basically just saying, hey, I want to change this value right here, or I want to take all of I want to create a new column that are much quicker, and that's the kind of stuff that we'll demo here. Okay, so now I have a link to this. Actually, you know what I should do is one more thing is make this so that I say target equals blank underscore blank. There we go. Run that one more time.
How is it like Excel?
Well, you'll see. That's what we're gonna do. We're gonna demo it, talk about what it does, and then you'll see. I mean, if you're not really familiar with Excel, then you might have to talk about it there. But it's kind of like Excel, except for you're programming everything, right? So yeah, now that opens up in a new window. That's why we did the target equals. Okay, so it's like Excel, but it's also it's got database query-like ability too. So so you can actually take a table and say, I only want this part of the table. So that's kind of cool. And you can group things, and it can still do slicing just like a list or any other sequence. And you can subset, index, you can merge and join. So it's really like a database. It makes your tables almost as if they were in a database. It has that ability where you can join tables and reshape and pivot. So we're going to demonstrate all of these items that I have here. So you can see how you can manipulate data using pandas. Now, because this is a GIS class, we're not just talking about pandas here. We're going to talk about the ArcGIS API for Python, because this is the module that ArcGIS has coupled with pandas. And it's a different module than we've been working with most of this course. This ArcGIS API for Python is a library that was really invented to interact with ArcGIS Online and other portals. So it's for working with not just geospatial data, but maps themselves. And it basically allows you to connect to a web GIS and interact with that. So you can even use it for uploading data into ArcGIS Online. Who's used ArcGIS Online? Some of you. So ArcGIS Online is at arcgis.com now, and Everybody has an account. You actually have to have an account to get into ArcGIS Pro. So one of the models that ESRI is moving to, that they've moved to now with ArcGIS Pro, is that ArcGIS Pro is tied to ArcGIS Online. You can actually put data up there just through ArcGIS. Just through ArcGIS Pro, you can upload to ArcGIS. So ArcPy installs with ArcGIS for desktop. ArcGIS API for Python can be installed by anyone. You don't actually have to have ArcGIS ArcPy on your desktop. Okay. Now, if you don't have ArcPy on your desktop, you can't do the little tinkery things, and you also can't run the tools. Okay. But if your tools can run on ArcGIS.com, then or some other portal that you set up, you could actually run them there. Okay. So the ArcGIS API for Python allows you to interact with data and the web GIS. In other words, the GIS that's in the cloud. And today we're going to demonstrate how it's tied to Pandas. Okay, it integrates well with Scientific Python ecosystem, and it has the support for Pandas and Jupyter Notebooks. That's what we're going to talk about this week. So here's the first set of code that I have in my in my Jupyter Notebook here, and what I've done is imported the ArcGIS module. I was talking earlier with Aaron about how you can connect to ArcGIS with basically you can connect and you have access to your licenses, and you'll have access to anything that you do have on ArcGIS.com, as well as your ArcGIS Pro licenses by importing this module. Okay. Now, if I still want to interact, which I don't right now, I don't have anything in the code that actually interacts with ArcPy, but if I do want to interact with like if I want to update features in a file geodatabase or in a shapefile, or I want to run any tool locally on this machine, I'm still going to need to have ArcPy installed. So if I want to run the buffer tool, let's say, and I have to have ArcPy installed. So I have to have ArcGIS on that machine. So that's why I imported that. Now, right now, I'm not using this, but we'll do some demos before the end of the class. This library, I believe I've used it before. It basically opens up a web resource, and I have this for an example later, but it's not included in the Jupyter Notebook yet. And then this is Pandas, the Pandas library, which we're going to talk about today. So this is how you import Pandas, kind of like how NumPy is usually imported. Most of the help on Pandas website renames the Pandas library PD, just so you don't have to keep typing in Pandas. So now we can access any function inside the Pandas library by just saying PD dot. Okay, and there's a bunch of functions that you can use instead of saying Pandas. If we just wrote import Pandas, we'd have to write Pandas dot and the name of the function. Okay, that's the difference there. All right, in Jupyter Notebooks, if we want to do plotting, we have to have this line of code. This allows us to do plotting inside of Jupyter Notebooks. Okay. We're going to talk a little bit about that library. And then finally, from this ArcGIS API for Python, if we want to interact with these Excel workbooks as if they're the data frames, really, we want to access these data frames as if they're spatial, we have to have this line right here. And it's going to import what's called a GeoAssessor, which creates a spatially enabled data frame. So Pandas works with data frames, but if we want the ArcGIS part to work, we also need to import this, which allows us to create spatially enabled data frames. And it basically tells the Pandas data frames that there's more functions that they can use that are spatial in nature. Let's talk about those as well. So I'm going to run this guy. And that didn't take very long at all to run, or no, it's still running. It shouldn't have taken too long. The ArcPy might take a few seconds. We're still having maybe issues with I ran everything before that. Oh, there it goes. So that ran. All right. So now I have two different lines. You don't need to run both of these, but if you run this line, you're going to make an anonymous connection to ArcGIS Online, and it doesn't give you any of the privileges that you would have with ArcGIS Online. It does allow you to create spatially enabled data frames, but for example, you couldn't save them into ArcGIS.com without logging in. Just basically, another way to say this is that this allows us to log into ArcGIS.com. Now, if we had a portal, which the university does now have a portal, we haven't opened it up to the university community at large yet. If you have a portal, you could put the URL to that portal. But right now, we can just connect to ArcGIS Online. And you give it your, the first parameter is the URL of the portal you're connecting to. And then the second is your username. So now I'm going to run this guy. And once you do that, it'll ask you for your password. You really don't need both of these statements. You either need this one or this one. But this, what happens when you say GIS is equal to something, it overwrites that other one. So now I can put my password in here. And one thing that's nice about doing this in Jupyter is once I hit enter there, and it runs through, I don't have to run anything above this anymore. So now I've imported all the libraries I want, and I've logged into ArcGIS.com, and now I can run these other tools. So first thing we're going to learn about is pandas, and then we're going to learn about spatially enabled data frames, or the ArcGIS part. So pandas is remember I said that the basic structure is a data frame? Well, the absolute basic structure is actually called a series. And a series is like a one column in a data frame, or one column in a spreadsheet. Okay? So you can create a series by giving it a sequence. So here I've created a random NumPy array. In other words, I used np.random.random number, and that random number that it generates 10 of them. That's what this means. So if I wanted to find out what this function did, whoops, messed up there. I could just probably Google it and look at the help, and it says, okay, well, it returns a sample from the standard normal distribution, and D0 is the dimensions of the returned array. So in other words, it's going to have 10 units. Yeah. And you could optionally feed it the mean and the standard deviation, but we're not concerned with that right now. Okay. So I just created, what this did is on display right here. It created a NumPy array with 10 units in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 units. All right. Now, if I want to convert that into a spreadsheet-like thing, a series, one column in a spreadsheet, I just call PD, which is pandas, dot series, and feed it the data. I could also feed it a list. I'm going to run this real quick. Oh, I forgot to run this one first. There we go. Now I'll run this one, and I get that. But I could feed it any sequence-like thing. So I could give it, PD dot series, and give it a list. 1, 2, 3, 4. This is probably good. So I can give it any number I want. And then now I run that, and that's my series. It just gives me one column of data, and these are the values in the data. I'm going to change it back to this one. So that's That's how to create a series, one column of data. Data frames are basically more than one series stuck together. Oh, by the way, one of the other characteristics of a series is that they're all the same data type. See how it found out that that was a float? And if I put that other line back in there, let's see if it'll let me do that. If I put that back in there and run it, it says that it's int 64. It figures out what they should be. That's one of the really nice things about pandas, is that it reads through all of your data as part of its package. It reads through all of the data in the column and decides, oh, everything is of the same data type and it's this data type. So if you put, let's see what happens if you put a string in there. Let's make sure that this is a string. Like, let's just write that. So now we run it, and it tells us it's an object. If you have a string in any of your data, then it's just gonna, object's kind of like the catch-all. It's like, oh, okay, well, you just want to be able to put anything in there. Well, then we're gonna say that this is an object data type. In other words, an object means give me whatever you want. You're just gonna store it, and it's going to be that. So if you have any string in there, it'll automatically say object, and if you have mixed types, it'll automatically say object.
So they're all strings. You say object too?
Yes, even if they're all strings, that'll say object. All right, and that's because a string. So pandas tries to be as efficient as possible, and so if it can sense that they're all numbers, numerical values, it can store them as an integer, and then in memory, it knows it needs to store a certain amount of space. Well, strings are weird because strings can be different lengths, right? And so instead, it stores that in a totally different way. It stores it just as a list kind of thing that can be shrunk and grown, and a list itself is actually an object. So that's why it says object. Because it can't depend on them always being the same size on disk. What's that?
The int 64, what is that next part?
It's a 64-bit integer, so it can actually store a pretty large integer by default. So it'll store a number up to 2 to the power of 64 if it's all positive, but if it's not, it's got negatives. It'll store half of that positive and then half of that in the negative direction. I don't know what that number is. But. All right. Okay, so data frames, so series are kind of cool, but data frames are what's really useful. So they have 2D structures that you can manipulate. So here is an example of creating a data frame. Now, one thing I don't like is that by default, if you try to create a data frame just out of thin air, like you create a series, it actually creates it the opposite direction. So every list item that you give it becomes a row, not a column. So when you create a data frame by scratch, so this becomes a row, that becomes a row, this becomes a row, and this becomes a row. Okay, and then I'm giving it fields. And so I'm showing you all these rows and the fields. And so in order to turn that into something like this, where it's got the rows on top, I need to do transpose. So I can take any data and turn it into a data frame, but by default, the data is going to be rows. In fact, maybe I should insert cell above. Just so temp df is equal to, yeah, this will be good. So I'm gonna run this. I got to print it. So this is my temp data frame. I'm just calling it df. So you could see that let's see, why did I run this one? There we go. I must not have ran that other one. Okay, so in this one, my temp df is equal to the data, and see how I've got each one of these 10 value random numbers created a row instead of a column. And that wasn't my intention. So I took so this function returns a data frame. This function then transposes that. What does transpose mean?
Copy?
It does, but it does something more than just copy. I'm going to take this.
Flips it backwards, so like if it's a row, it's a column.
Exactly. It changes all the rows to columns and columns to rows.
No, so go. Inverse.
Yep. Insert cell below. Make this markdown. Run it. And then this is when I turn it into a data frame, the sequences of data become rows by default. Okay. All right. So that's to explain why I added that one. All right. So yeah. So transpose turns it into columns were rows and rows were columns. Then this function right here renames the columns using the fields, which were right here. See, we got 0, we're going to rename it red. 1, we're going to name it green. 2, we're going to name it blue. 3, we're going to name it height. So this is, by the way, what is this right here? What data type is that? Yes, it's a dictionary. So we took a dictionary and we applied it using this rename function. And we said that we want the columns to now equal fields. And so it goes through, and basically they've written, the people that have created pandas have written a for loop inside that says, for every column, rename the column, fields, and then the index of the column. So 0 gets red, 1 gets green, and 2 gets blue. Okay, and then I'm going to convert the last column from being a floating point number. I'm going to turn it into being an integer 32 column. So I can actually use this function to convert any column from a certain data type to another data type. So that's what's happened here. So I've got red, green, blue, and height. And right now this is just random data. I created it randomly. Now, I don't really like that. I would rather create all my columns and glue them together. So that's what this code does. It builds a data frame column by column. But you have to build series first and then glue them together to do that. So here I've created a series just like I did, up here where I created a series. Okay, I'm just giving it a random list of numbers, another random list of numbers, and another random list of numbers. And I'm giving them the name red, green, blue. And then finally one more random list of numbers where I convert it to a type int. And then I use this function instead of creating a PD data frame like that. I create the PD. I say pandas.concat. Concat will combine two series, or it'll combine 2 data frames, or 3 data frames, or 5 data frames, or 2 data frames in a series. It'll just concatenate them. What does concatenate mean? We used the term before. What's that?
Just stick together?
It'll stick them together. So it's sticking together column 1, column 2, column 3, and column 4. And then it'll tell us which axes it wants. If you do 0, it'll actually concatenate them this way, which is not what we want. We want to concatenate them this way. So it'll stack them. If we said 0, and axis 1 is the other direction, so it'll stack them vertically.
Even though they're series, it will still stack them on their side.
Right. Yeah. Well, it'll do something like here. I'll just show you what it does. See how it stacks it like on top of each other. It's still one series, but they're stacked this way. So the series are still columns, but it's stacking the columns down that way. Whereas if we say 1, it stacks them across. So now it'll create a data frame if there's more than one column stacked across. So now we have a data frame. Okay. All right, and one of the cool things about Pandas, just like Excel, it comes with the ability to create charts, but these charts can just be created through code. And so all of the charts can be created by referencing your data frame and then saying dot plot and then dot, and there's a bunch of different plot types. So you can just go pandas, plot, probably. Yep. So see if there's a big list of them. There's a bunch of examples. It's always nice to look through the examples. Other plots. Okay, so this is an example. This is the list of all the ones that are possible. Bar, histogram, box, KD for kernel density estimation, area, scatter, hex bin, pi. You can actually build very complex plots if you go and tinker with the actual matplotlib library. But for lots of basic plots, like you would see in Excel, you can use this. So I'm gonna actually take this back in here and edit this guy and put that link there. So now we've got a link to that. Okay, so here's an example of a scatter plot. Did I run? I ran this one, right? Yep. Okay, I'm run this one. So that's the example of a scatter plot, and it just takes the data and it displays what. So what does red mean here? Does it mean a color? What does red mean in this case? Yes, the x-axis is the red column, and the y-axis is the green column. So it's just plotting the location of this x and that y on this column. So if I change this to height, and I tried to run it again, now I'm going to get a different chart. This is the relationship of red to height, whereas this is the relationship of red to blue, let's say. Okay. Oh, okay. The C is the color. So I've said it's dark blue and the dots. So if I change this to pink, I should get pink dots, which doesn't look very good. So I'll leave it dark.
So it could be any color name?
Yes, it can be any color name. It could also be a hex color. So you could say FC0. I don't know what that's going to create. Oh. Maybe it needs to be a two-digit hex.
So like if you type magenta, it'll show up magenta?
Depends on if that's in the library. But yeah, so sometimes like HTML is okay with a 3-digit hex, but they're not. So you need a 6-digit hex. So a hex is a value where the first two represent the red, second two represent the blue, and the third two represent the green. So let's see if magenta is in there. Is that how you spell magenta? I'm not even sure. Yep.
I think so, yep.
Yep, so that worked. And if you go back to this page and you click on, we're on scatter, or any of the other ones, and then you look at this button, you can see that these parameters are that it'll take. It takes X, Y, S, which is the size of the point. So if we wanted to adjust the size of the point, we could do that in code by just saying, S equals 10. Now run it again, and we should get bigger dots. They look smaller. Maybe we'll make them really big. Let's do 100. Yep, okay. So I don't know what the scale is there. It'd probably give us a good example here. Probably give us a good explanation if we actually read that. Now, we can also feed it any keyword arguments to pass on to dataframe.plot. And there, basically, what it'll do is anything that's available for matplotlib. So we could go in here and look at all of these different things. We could pass on any of those values. Let's see, alpha. Let's see if that works. Comma alpha equals 0.5. So did you see how, I don't know, let's do 0.2. Did you see how those got less, they got less they're more transparent. That's what the alpha means. There's this dark blue. Okay, so we added a few different things that we could change. Right?
Less transparent.
What's that? That's transparency. Alpha is transparency. Yep. So we could also change the size. There's a bunch of different things. I've got an example down below that changes the size, so I won't do that here. But we can control the charting really well. Okay. All right. So we can also do bar charts. So here's a bar chart. Yeah. So what is the rot is the rotation.
That makes them up and down.
Well, here, let's just do the help here. Bar. Plot bar method. Okay, so that's actually the rotation is actually. I actually just cut and pasted this from the help. So the rotation is not the same thing as whether they're horizontal or vertical. You can actually make them horizontal or vertical by putting in bar H right here. I think rod 0 is the default. So like it's not going to produce anything different. Let's see what happens if we do that. Also didn't change anything. Yeah. So anyway, you can make it vertical or horizontal that way. All right, now by default I only added a Y, which was the height. And look here, I didn't put any labels down here, right? How could I put labels down there, do you think? Yeah, X equals. Let's see what field we want to do. So by default, if you don't actually put an X, it puts this column, which is called the index. So data frames always have an index associated with them.
It's almost like an ID column.
Yes, like an ID column. Okay, so if you don't specify what you want as the X on a bar chart, it's always going to choose this column. So that's why it did that. But you know, if we wanted to say comma Y, or sorry, X equals red, we could. It doesn't make a whole lot of sense here, but we can run this, and you see how it just puts all the values that are in this column. See why that doesn't make any sense. So.
Maybe rotations rotate the numbers.
The labels?
Yeah.
No. That would be a good thing to do.
You can make those like 45-degree angles. Would be nice.
Yeah. So we could look. I want to be matplotlib.par. Label. I'm pretty sure that's going to be something under tick labels. Got to be a way to. So we probably want to say matplotlib because that's going to be helped in matplotlib. Say rotate tick labels. Okay. So rotation equals vertical. Okay, well that's.
Wonder if you put like 45 and it'd be 45 degrees. You know, like how 45, you put negative 45 and you want it in the opposite direction.
Yeah. So yeah, it looks like it is. It looks like you got to get the plot and then rotate it. So you can do it, but it doesn't just work by just putting there's not a value in there. So you see how what I'm trying to say is see how this actually returns a bar chart, and inside the bar chart you can get the labels and rotate them. All right, I don't want red to be what I want to show there. Okay. Sometimes to get a chart, well, actually all the time, to get a chart to look the exact way you want, sometimes you got to really dig in the help to get it. But it does a pretty good job at creating a quick and dirty chart, just like in Excel. Anybody use Excel? Getting the chart the way you want it is oftentimes a pain, right? And it's not any different here. But the nice thing about it is once you get it the way you like it, and you have a code, you can actually create a function, pass the chart into the function, and it'll always format your charts the way you like your charts formatted.
That'd be good for like a project and run all the same throughout the project. Change the value.
Right. I was going to show this later, but this is an article I wrote a long time ago, 2015. It's not that long ago, I guess. Yeah, I didn't mean to say a long time ago. But the charts in here were all created in Pandas. In fact, the data was queried in Pandas. So you get charts that look like this. These are basically bar charts. You can kind of tell they were created in Pandas, right? And you can create these like double bar charts by getting a little bit more fancy. But this is just a bar chart that's been rotated. And these are the labels. So this was the label. This is the country. But the reason I was going to show this later is that you'll even be able to see how you can manipulate the data to look like this, because I'll describe the original data. All right, so that's a bar chart. There's several other types of charts. Another thing that you can do with Pandas is you can create new columns really easy. So I created this new column called majority. And the only thing I had to do to create that was reference my data frame and then call it majority. Okay. And I don't know if majority is the right label, but what this does is it uses a where function. You can use dumpy if as long as they're all values that would be in an array, you can use an array function, and it says if the value of red is greater than the value in green, then make it red. If not, make it green. So in other words, what I'm doing is assigning everything where red is greater than green, I'm assigning it red. And everywhere where green is greater than red, I'm assigning it green by using this function. Okay. Then this function, what it does is it then says, okay, well, re-examine what's in majority, and if blue is in fact greater than red, make it blue. If not, leave it majority. So it's basically just two logical steps, and what happens is whatever the highest value is out of these three values becomes this value over here. I could do it more simply, like maybe I shouldn't have been, I could just go my df zeros equals 0. So this is just a very simple, like this has a lot of logic in it, but this just shows you I can create any new columns by just doing that. And I can actually set them equal to any other column. So I could make this a red or total. I could just say red, because I can access any column as a series. I could do red, green, blue. Does that make sense? So now the total is going to be the value of this one plus this one plus this one. Okay. So that's just added all those up. And there's actually another way to do that, which we'll show in a second. Right here, this is where we'll do it. But this is actually using a group by too. But I could just just say total. All right, so we can also group the data by a certain field. So in other words, I can take all of the ones where red was the majority and group them together, blue and green, and so on. It's very much like an SQL statement in a database where we do a group by. Now, in terms of ArcGIS, this is kind of like a dissolve. We're basically dissolving on majority, and we're saying that these are the fields that we want to summarize, and this is the summary statistic that we want. So when I run this, what I get is I get the average value for the reds. For the blues. Everything where blue is the majority, this is the average red value. Everywhere where blue is the majority, this is the average green value. Everywhere blue is the majority, that's the average blue value. So it makes sense that that's the highest value, right? Because that's the average blue value in the areas where blue is the highest. Okay, and this is the average height value for those. And then I could do a bar chart of those values. So now I've created a new data frame. This is a data frame that looks like this. It's my old data frame, but it's grouped. So I've created a new summary. So now you can see that on average, the blues have the highest value. The greens don't have the highest value. The reds have the lowest height on average. Things with a red majority. So this data is all made up, but picture this being like, a bunch of plants, and I'm giving them red, green, and blue light to see which ones grow the tallest or something like that. Okay. All right. I can also describe my data frame. So here, when I describe a data frame, it tells me all of my columns, and it tells me how many there are, what the mean is, what the standard deviation is, what the minimum is, and then the 25, the 50, and the 75 for each one. Okay?
I do have one quick question.
Yeah.
That bar chart, did it, oh wait, no, so you assigned it colors, and it just knew to match them up correctly?
Oh, yeah. Yep. So that is one of the parameters for the bar chart, is that you can give it a list of colors, and it'll just put them in order.
Okay, so just what happened, we fed it blue, green, red.
Right.
And it had the colors in blue, green, red.
Yep. So if I did this, then that bar would be purple, even though it's... But I want it to be blue because I want it to... In fact, you know what might be interesting is, see, these are blue, green, and red, and that is the index column, right? And so I actually can't. So here's what I'm trying to say. So if I print, I'm sorry, not print. If I just say, if I try to reference that column, I could go like this. So I want that series majority. I do think I do this later, but notice that it gives me an error. It says the key error majority. The index column, you can't reference it, okay? Unless you say, I forgot what it is off the top of my head, but I think I do it later. Something index. Maybe I'll just index. Reset index. There we go. It's way down there. So I'm going to go way back up here, and I could take the that, and if I reset the index, it basically will turn the indexes back into zeros, ones, and twos, and it will make the index column a column in the data frame. So now I'll have blue, green, and red is that value. So I wonder. I'm just thinking here. I could say color or CL. I'll just say CLR S is equal to this, and see if I can just feed it. So one of the nice things about pandas is that sometimes when you think I should be able to do this, you could do it. Like pandas is not so concerned with all the data types matching. So this is actually kind of a list-like thing. So I should be able to feed it a list-like thing, and maybe it'll work, but I don't know for sure. Yep, it works. So now what I'm doing is I fed it this column's worth of data, and that became the colors, and so it's reading that from that list. So even if next week I had a different data set and it wasn't red, green, blue, it was red, green, and purple, it would get the right color. I didn't have to type out that list of colors to make the bar chart look right. So I generalized it basically. Okay, so here I'm describing my data. I already said that. Well, this data that's here is actually the same sort of data that's here in the box plot. Notice that they're changing a little bit every time I run them, and the reason that is that when I every time you run the random thing, you get a new set of random numbers. All right, so on here you have the mean of red, the mean of green, and the mean of blue. That's what the green line is. That's what a box plot is. Anybody know what a box plot? You guys have used box plots before. So this is the high and this is the low, the min, the max. That's what the whiskers are. And then this is the mean. And then these are the 75 and 25 percentile. So that's these numbers right here.
See, there's a lot with grades. Like,
Yeah, so it show you the distribution.
the
Exactly.
green line's the mean, right?
Well, I'd said that it was, but I wonder if it's actually the median, which is this is the median value, the 50% value. Let's see. This one is, it's hard to tell because they're so close together in this data. This one's the furthest apart. Yeah, it looks more like that's just under halfway. So that would be, no. Wait, mean for blue. We're just doing blue. Okay, so that's just under halfway. So that looks more like it's the mean to me. And then those are the 25 and 75. Yeah, that makes sense. Actually, it would always have to be the mean, because it was the median. It would always be right in the middle of the data. So it makes sense for that it's the median, because it shows you how far the data. It tells you how much the data is skewed. So the green column is hardly skewed at all, whereas the blue column is skewed toward the taller plants. Or yeah, I guess it's not height, but you get the idea. Okay, so you can ask for all the columns in a data frame or all the data types in a data frame. That's what I did here. So it will return a list-like thing of, if you say mydataFrame.columns, it'll give you all the names of the columns. So you could iterate over them if you needed to, or you could iterate over the data types if you wanted to. Okay. All right, now we've already demonstrated a little bit of this, but just to be clear, we can slice up a data frame in two different ways. We haven't done by rows, but we've done by columns already. So if you give a data frame a list of column indexes, which are always these values, then it will only return those columns. So that's actually what I did, like right here. I was giving a list of columns. That's why it didn't actually return this total column in my output, because I only had those. Right? So here I'm saying I want this data frame, but I only want to see the red and the green columns. And the iLock accesses a row, so I'm saying I only want to see rows 4 through 7. And I could create a new data frame. I could say new df is equal to that subset of the data frame if I wanted to. Now this wouldn't show anything unless I printed it, but now I've assigned new df to that variable. Okay. So if I want to get a subset of my data, now it's more likely that I'll want to query it. In fact, I should show that too. I'll show that right here. New, insert cell below. It's more likely that I'd want to take my data and say this dot. You can use the query function to specify a query, and you write this in the same way you would write a query. So you say green is greater than 0.5. So now I've only gotten those values where green is greater than 0.5, and I've only gotten the columns that I need. I don't even think that the column needs to be there. Nope, it does. Okay. Actually, maybe if I did this, the column wouldn't have to be there. So I could do that and say blue. Because when I chain these together, yeah, so I guess not. I guess that does have to be there. I thought if I change them together, it would do them in order. But, yeah, it looks like they need to be there. All right, so now I've just got those columns. All right, now let's try this with some real geographic data. And this will also help us to be able to understand how to utilize what's called a comma-separated value. So I'm going to start with a comma-separated value data set. You guys know what that means, right? So if I go into here, week 10, and I open up this this data set, it's called selfie deaths. I think I talked about this in my other class. So this is the raw data, okay? And it has a few fields. It has a date field. That's how it came. What do you think those dates represent?
The date they died.
Yes, but it's not the exact date. If you look at it, there's not enough digits.
The year.
Yeah, it's just the year and the month. Okay. Then we got location. We've got casualties. We got type, latitude, and longitude. If you have a data set like this on, wherever you get it, you can easily read this into a pandas data frame. In fact, if it has a latitude and longitude value, you'll be able to convert it into a what's called a spatially enabled data frame. So we're going to cover both of those. You can also create a spatially enabled data frame from any data set that's already geographic. Okay. All right. So I got type, latitude, longitude. The way that I read a CSV into pandas, it's really easy. I specify a file name, the location. Since this Jupyter Notebook is running in the same folder, see how it's running in the same folder as the data, I don't have to type the full path. But if you want this to run on yours and they aren't in the same place, you need the full path. So you need C : whatever. Okay. So you do that, and then all you need is this pd.readcsv. And I only put this in to kind of demonstrate what this does. Is this fills any missing values with a 0. That's one of the nice things about pandas, is you can fill missing data in really quickly. And then this line right here takes the data and shows us just the heading. I'm going to go ahead and rename this because I actually was using a different data set at first, and it was kind of cool, and I'll demonstrate at the end. But I was afraid that on the other computers, because it takes a little while to download, that it's a lot bigger data set, and also it wouldn't actually save in GitHub. It was too big, so I switched over to this one. So I'm going to run this guy, and now we can see this. When I ran this, that's the output. So I can see that, and this is kind of a neat thing to do, is to say dot head. It'll just give you the first 5 records. You could also do dot tail if you want to see the bottom records. It just makes it easier to inspect rather than looking at every single record. You could still see what the biggest number is, and that sort of thing. Okay. All right, so this is the code that actually converts it into a spatially enabled data frame, and I need to change selfie deaths here to. I did it throughout it. I just didn't do it at the very beginning. Okay, so what this does is it takes a data frame, and this is an ESRI function that they've added into pandas, and this ESRI function converts a data frame into a spatially enabled data frame. And here we're saying it's from XY data. Now, there is a method that we'll talk about later for just taking regular old data and turning it into a spatial data frame, like a shapefile and turning it into or a geodatabase.
Can you take like an address?
Yes, you can from addresses. We can look and see if we get an example of that.
That's when you want the ESRI to run a Panda data into the Python function of it.
Yeah, to run this is where we're getting into. Needed to have. We're finally getting like all this stuff didn't need it, but we needed now to have this line and this line in there. Otherwise, it wouldn't work. So we're actually using the ArcGIS for JavaScript. I mean, sorry, the ArcGIS for Python library. See how big this one is? So if I run this guy, I get the full thing, and I might not like having that whole thing there. So I could just say dot head, and now it's only going to give me the first 5 records. Okay, so it'll be easier to see in my. Doesn't mean that it's. Now if I actually went like this, I'm not going to run this. If I actually went like this. What's it going to do, and why is that bad? Well, it's going to take my SDF selfie data frame, it's going to sort it, and then it's going to take just the heading, and it's going to reassign it to SDF selfie. So now my SDF selfie will no longer have all the records, it'll only have the first 5 records. I don't want that. So that's why. So when I do this, I'm just doing this for display purposes. So I know the SDF selfie is bigger than this, but I'm still just showing the head, and I'm actually sorting it by the date. But I haven't talked about that yet. So let me.
You're skipping the 4th one, huh?
What's that?
It goes 0, 1, 2, 3, 5.
0, 1, 2, 3, 5. I don't. Yeah. What is it?
Is it because of the O:4, like on the top with the years and months?
Oh, well, I sorted it, and so the index stays the same regardless of sorting. So see how I sorted it right here? And so if I run this, 0, 1, 2, 3, 5, 6, 7, for some reason there's 9. So for some reason they're pretty close to in order, but they're not in exact order. In other words, the CSV isn't sorted by date. So this is 0, 1, 2, 3, 4 is the 0, 1, 2, 3, 5. That's the order it appears in the file.
Okay.
And then I say I sorted it. See, if I didn't sort it, let's just comment that line out and I run this. Now it goes 0, 1, 2, 3, 4, 5. Just like in Excel, when you sort something, you see it sorted. But in Excel, it kind of does change.
But
So,
that ID field stays locked with that data even if it moves up and down.
right. It really is like a unique ID. ArcGIS is the same way. Like if you have a unique ID and you sort it on time, then your unique ID field would change around. So it's very much like that.
So it's not putting it in order like that. It's just sort of one time field. It's not
Right. So this is just a representation of the data. Yeah. Now, if I did this, that's the point I was trying to make. If I did this, then I'm taking the representation of the data and I'm saving it out, and I'm saving over the old representation of data into the new one. So then now SDF selfie would be sorted if I did that. So
You'd only have the first 5 too, right? Would it
yes,
delete
I'd
all
only have the first 5.
And it would delete all the rest of the data?
Right. Yep. Exactly. And since I don't since I don't create this until way back up here, I'd have to rerun this to get that to work. But here, now I'm going to run this right here and just say SDF selfie, and you'll see that these now would be 0, 1, 2, 3, 4 because I basically I didn't. Oh well, yeah, it didn't do that, but the head part would definitely work. Head. See, now it's only just the heading. I don't know why that index stays permanent, but I guess it's because it's a different.
But it is sorted about order of time.
Yeah.
Can you do the head and the tail at the same time?
You can print both.
Like if you want to do the first 5 and like if you want to do the first 5 and the last 5.
Yeah. You could print both. You could do. You'd have to write print though, because it only interactive Python only shows the last command. I wonder if you, because this is technically a tuple, if you put a comma in between them. Yeah. So you can see them both. It doesn't format them as nicely because it's a tuple now. But anyway. All right. So now we have that, but it is the whole entire thing still. So I just want to see just the top for now. Okay. So I already did that in the next column as I made that point. Actually, I could do head here, and then I'll do tail here. So there we go. Run. So this is basically for interactive Python. By the way, I didn't finish talking about this one right here. Okay. So this date, what data type is that? It's a column of numbers, but we don't know for sure if it imported that as a string or if it imported that as numbers. We don't know. But how can we find that out?
Could you put it on that type?
Yeah, we could just go like this and say SDF selfie.dtypes, and then we can see that date is actually an integer 64. Okay, that's what it is.
What is that now?
That means it's a 64-bit integer. In other words, it's a number between 2 to this. It's probably 1/2 from negative 1/2 2 to the 64th to positive 1/2 2 to the 64th. So
the date time function on there convert into actual numbers. They put that line in between because we didn't change the value of it. I mean, you look up and see you see one end on one side and the other end is like regular breakdown. I'm not talking about in that column over there. You know, where you got the columns.
Yeah.
Daytime and date that, you know, they look like they reconstructed that in a way.
right. So that's actually what I did. So this was the original file. Okay. And then I turned it into a spatially enabled data frame first. But that's in fact, insert cell above. Let's move this part up into there. And then I'm going to do SDF selfie.head so you can see the difference. So here it doesn't have the well, okay, I got to rerun this one because now I've run it and I copied over it. Okay. So now you can see after I run this line, I don't have those date times. I just have this date. So this function right here, or this code right here, adds these 3 columns because I want a date time function. Right now, I don't have a date time column. I only have an x64 column. So what I did was I used this thing called a lambda function. We haven't covered this yet, but a lambda is a way to write a little function. Okay, and there's a way to take a column and apply a little function to that. So the way that you read this kind of complicated line is so first of all, we'll start here. I'm going to create a new column called year, and I'm going to make year equal to the data frame, the column date. I'm going to say for every value in date, apply this lambda function. So in other words, when the first time through the loop, lambda is going to equal that. X is going to equal that because that's what SDF.date is. And it's going to apply this function. So it's going to take that value and put it in X, and then it's going to convert, this is the function it's going to do. It's going to convert X into a string, and then it's going to do the first 4 letters of that string. See that?
And that's the year.
That's going to be the year.
Okay.
And then the month is going to be the next 2 letters of the word string. So it's going to be the 4th through the 6th. So there's going to be 1, 0 in this case and 1, 2 in this case. So that's why in this column, I've converted year to 2001 and month to 10. And then I just made all the days 1 because this data didn't have dates associated with it.
But if it had different dates in there, then what would you do? Just in
other words, if
01 or 02,
if
you might have 01 and 07 would be the 7th date. So
right.
you would just say that it would be one long number.
Right, like if date was longer,
Uh-huh.
then I would say the next 2 digits would be like 6 through 8 would be those 2 digits.
Okay, I got another question because I'm gonna try to do this for another time. So what if, just take for the instance, the land 0 under the date. Now,
Where?
on the columns at, because I got some data that has this item, but it's all separated by commas, right?
Yeah.
So then I can convert that to Panda data. Because
Yep.
all I got is the data that say comma, 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 comma. Everything you stand up there, the date, this event happened, but it's all in commas, and it's like hundreds of lines. So I want to take each one of them, but apply a formula that converts it all into like a Panda chart.
Yeah, that's actually going to be the assignment for this week. Is you identify some data and you tell me what you want to do with it, and then I'm going to demo some of them next week. So if you have that data, you want to use that data. Yeah. Now it does have to be data that you can, because it'd be nice if it was data that we could show on a map at some point.
Yeah, well, it is information
Okay,
showing.
good. Well, then it'll qualify. All right. So this basically creates this column, this column, and this column, and then this line of code runs a method called toDateTime that converts year, month, and day into a date. Okay, so now I have that date. So I can now sort on the date time if I wanted to, which is what I did. I sorted on the date. Okay. Let's see. I could also run that. Let's see if we've got. Where was that? So some sort of chart that might work for that. Like one of these charts. Pandas. Okay, so see if we could quickly, because this is now time, right? Let's see. I don't know for sure if we can just copy this code in, but let's try it out. Of course, this one has columns, but does it actually mean something? Copy that in here, and I'm going to try to run this. So Looks like the data there. Okay. Yeah, this looks like it's not setting up the entire chart. I'm trying to see if we could do a. Yeah, maybe I'll put that example in later because I'd have to read over this and figure out how to make it into this time series chart because this is referencing code that's actually not on this page. This is just showing you how to set up the data. All right, so we'll do that. We'll do that later. In fact, I could put a comment in here and say, try and show time series chart. Okay. All right, so that's that. We're gonna run that guy. It's the tail. All right, so now, what if we wanted to see this on a map? Well, we can use the GIS to create a map. So we created a connection with GIS, and there's a method on that GIS element that we created. Remember, we connected using my credentials. So I can run this, and it will create a map widget on our page. So here is the map widget. It takes a few seconds to load. There's the map widget. Now there are ways to have this zoomed in to different areas by default. Those are different parameters you can feed this. So I don't know if we can find the help on that. Yeah, so we could set the zoom level by doing that. We can set the rotation. I don't know why you rotate a map, but you could. You can set the center. So let's do that real quick. So instead of just setting this up, I'm going to do M1 stands for map1.center. I don't know where 3418 is. I'm going to run this and see what's it. Yeah, so see how it slid it over a bit? Because 118 is now the center, which is like over here somewhere. 0 is the center, the longitude. Run this. We should be right over. Yeah, so right about here. Where are we? 89? So now we'll just have it centered over, our area. So anyway, there's lots of things you can do there. So we've put our widget on. Now we can start to add data to it. So this is how we add data to it. We use the data frame. We say dot spatial, and then we plot it. Everything that's under dot spatial are the new things that ESRI has added. So I'm going to run this guy, and here we'll get a map of all of the selfie death locations in the world. So got that map. Okay. All right, now I did this later, but I also want to do this right now. I want to make it so that I get to see these by type instead. So here is the line to do that. Oops, trying to zoom in appropriately. So here is the way that I would do that, is say spatial.plot map widget 1 rendering type unique value, and the column is type. So now if I rerun this, it's going to change the color. I can zoom in now and see. Like, it looks like the blues are drowned, and the greens are firearm. I don't know why you'd die in firearm from taking a selfie. Maybe somebody said, "Hey, get off my lawn," and shot him or something.
I did Russian roulette.
Yeah. Transport. So in India, there's actually a fair bit of these transport ones. That's the light red. There's lots of people that take pictures of themselves on train platforms, I guess. So that's animal. Wow. So somebody took a selfie like with a tiger in the background or mauled them or
Fell over
something.
the side of a zoo or something like that.
Yeah. So they got
So
animal.
did you make a particular field a type, and that's why it identified as those colors? Or did it just
Yeah,
read
so-
back to this?
So if we look back at the data, if we go back, that's right here. If we look back at the data, there's already a column called type. That's why I'm using that column.
All right.
So here, when I say that I want to use the column type as the unique value, it does that. So we don't have too many in the United States. So this is, since they started keeping records on this stuff, I don't know exactly when that happened. Luckily, nobody around us has ever,
Houston.
no Mississippi, Houston, some guy shot himself, or somebody shot him when he was taking a selfie.
Is this about
You're like
5 year
posing with the
range?
gun and then accidentally pulling the
But
trigger.
this just a small sample, like 5 years or something. Is that a?
Yeah, it doesn't go very far back. Drowned. And then, yeah, transport. Now some of these guys like down, some of these,
What's the light blue?
the light blue. Where's that? Oh, right here. Electrocution. Sounds bad. Transport.
Suppose you wanted to add.
Fall. Yeah, that's what it is. So see down here in the tip of Malaysia, there's like a really tall tower. And so some of these people climbed up on really tall towers and fell. Anyway.
Look at India. India has so many.
Yeah, India's got so many. I don't know why.
Because of the population, it's a big party.
There are a lot of people.
They're almost like China.
Yeah.
Yeah.
There's still people.
Oh yeah, but there's still a lot of selfie deaths.
Okay, now,
Concentration.
suppose you wanted to get the age, but you didn't have age in your initial data. Could you go back and create a field for that?
You could create a field called age, but how would you get it?
Into that data. So, I mean, if you just
Like the age of the person or the
Yeah, the
how
age of
long
the
it's
person.
been?
the age of the person, if you found that data, you just have to just redo everything from, just insert a column in there and then.
Yeah, you could insert it. You can add another column,
Okay.
but you'd have to have a way to glue them together. So the two data frames would have to either be the exact same size, and you could just concatenate them. In other words, one had 175 records and the other one had 75 records, and you knew that they matched up perfectly. Or they have to have a column.
Associate name, a name.
Yeah.
Name attached to it.
Yeah. So you can do pandas join. You can join data frames based on a column.
Okay.
So, yeah, it's actually, the command is called merge, but you merge them based on a column. So this is the column from this data frame, and this is the column from this data frame that will match. Yeah. And actually, one of the things that ArcGIS allows you to do is you can do spatial joins. Now we might not have covered that too much in this class, but you can actually do a spatial join with data frames as well. All right, so I can also group these data. So here I've taken the selfie data and I've grouped it by type. And I've gotten the average latitude and the average longitude of each type, and then I took the number of casualties and I counted all the values in that column. So that's what that does. But
Do you do that to see a pattern?
yeah,
You got different ways of looking at it.
right. This is just a different way to look at it. So I run that one. And I'm going to manipulate the data a little bit. I'm going to turn it back. So by default, when I run this, I get see how I get two data frames? One data frame is the latitude, the average of the latitudes and the average of the longitudes. This data frame is the count of the casualties. And I want to put them back together. And I can put them back together by merging them, by joining them on the type column. So they'll have that type column, and they'll be linked together by that type column. So this is doing a join. Okay. And then I rename the column that was called casualties, and I rename it count because now it represents a count. I don't have to do that, but I think it's just easier in my brain to do that. And then I recreate a spatial data frame using the latitude and longitude fields. And then finally I sort that by the count. So now you can see that the number of fire selfies was 1, the number of fall selfies was 66. So this was actually the most common. If I wanted to chart that, I could take this data frame and chart it using a horizontal bar chart, and I could see that falls were the highest. They were more than drown, they were more than transport, they were more than execution, and so on. I could go back up here. That's why I have this commented out. I could change this so that I only look at 2019, and I would call that something else. And then I'd have to change both of these lines too. And I could run this, and then run that, and then finally run this again. Whoops. No numeric. So there's basically, let's see what happens. Oh, so in 2019, there's, it's a string. Do something like this. There we go. So now we only have animal